Hey guys, it's Mr. Schmidt here, and in this video, we're going to look at topic 2.3, which is the price elasticity of demand that's found on pages 441 to 445, and then 447 to 453 in your textbook. So basically, what we're looking at here is kind of a bit of a detour from the graphing we've done with supply and demand, although we'll do a tiny bit in this topic. Really, what we're looking at here is how sensitive are buyers to price change, right? We talked about demand. We talked about this idea that the law of demand states that when the price increases, quantity demanded decreases, right? That's the law of demand. We learned that 2-1. What we're learning here is how much quantity demanded changes depends on the consumer or group of consumers, right? If the price of your favorite candy increases by 20%, you might still buy in the same quantities. Whereas someone who just has an okay opinion of the candy might buy a lot less than before, right? So elasticity, which is the sensitivity to the price that we're going to talk about, varies depending upon what consumer or group of consumers we're talking about. So I mentioned that word elasticity. It means how much one variable changes in response to the change in another variable, right? You might see this in a science class, for example, right? So if I change the soil, how much does that change the height of the plant? In this case, we're looking at something called the price elasticity of demand, or PED for short, and that's how much quantity demanded changes in response to the change in price. So, for example, we know that when the price of a good increases, the quantity demanded will decrease, but by how much, right? That's what price elasticity of demand, or PED, is getting at, is how much does quantity demanded change when there's a change in price. So elastic demand would be quantity demanded that is greatly affected by a change in price. So for example, if the price of Cheetos or your favorite snack food tripled, you would probably buy a lot less of it, right? Because there's plenty of alternatives to Cheetos. You don't have to go with Cheetos. And so it would have very elastic demand. Elastic kind of just means big change, right? So if there's inelastic demand, there's going to be a big change to the quantity people want to buy when the price changes. The opposite case is inelastic demand, where quantity demanded is barely affected by a change in price. So, for example, if the price of a life saving medicine tripled, you would buy relatively the same amount. You're not just going to say, okay, this medicine's more expensive, forget it, I'm just not going to buy the medicine, right? If you can afford it, you will continue to buy it because you need it. It's a necessity. And so the demand is inelastic or not elastic, meaning the quantity demanded is barely affected by a change in price. So what I want to do now is make this little chart to kind of help us understand what kinds of goods have elastic demand and what kinds of goods have inelastic demand. So the first one is the number of substitutes. The more substitutes you have, the more elastic the demand is because there's more choice, right? The more choices you have, the more price becomes a factor, right? If there's 5 brands of paper towels and one of them is much more expensive than the other 4, you're not going to buy that brand of paper towels. Whereas if you need a life-saving medicine and there's no substitute for it, price becomes a lot less of a factor in your buying decisions and therefore more inelastic demand. Second, is the good a luxury or a necessity? If the good is a luxury, then if the price goes up, you're like, it's a luxury, I don't need it, I just won't buy it. But if the good is a necessity, it's going to have more inelastic demand because you have to have it, right? Like that life-saving medicine I've used as an example before. The third one is how addictive is it? The more addictive something is, like cigarettes, for example, the more inelastic the demand is. And this is why the government taxes cigarettes so heavily, because they know people are going to probably keep buying them because sadly they're addicted to them, right? In a lot of cases. And so therefore, the demand's inelastic. You're going to make more money off of those people. Fourth one is what percent of income does it take up? The more money you spend on something, the more you notice a change in the price, right? Like if my rent doubles, I'm going to really notice that, right? Because it's a large part of my income, where I put my income. But if the price of Cheetos doubles, I'm like, who cares? I'm just not going to buy Cheetos, right? So it depends on the percent of income, right? So more elastic demand, larger percent of income. And then finally, how much time has passed, right? If you need gas today and the price of gas is $5, it's shot up to $5, you're still going to get gas because not a lot of time has passed and you don't have a lot of time to change your behavior. So very inelastic demand. Whereas if a lot of time has passed, you have more time to change your behavior, more time to find alternatives, substitutes for the product, more elastic demand. So with that in mind, let's do this practice here. So go ahead and indicate whether each of these goods has elastic or inelastic demand. All right, the correct answers are going to be inelastic, inelastic, and then elastic. So toilet paper has inelastic demand because it's kind of a necessity, right? Same thing with gas. Pizza, a lot of substitutes, more elastic demand. All right, now what was maybe a little challenging with that practice is it's kind of subjective, right? Like if we use this chart, that's pretty subjective, right? As to whether something's elastic or inelastic. Like how many substitutes is many versus a few. So a formula is helpful in spitting out a number that will tell us whether the demand is elastic or inelastic or something else. And so the formula is the percent change in quantity demanded over or divided by the percent change in the price. That is the formula. And using this formula allows us to determine whether a good has elastic or inelastic demand. So, how does the formula work in practice? So, one thing you do need to know how to do is to calculate percent change. So, the way to do percent change, if you don't know, is to take the new number minus your old number divided by your old number times 100. And that will give you the percent change. Sometimes they'll give you the percents. Sometimes you have to calculate them from two quantities demanded or two prices, or in the worst case, the hardest case, both. So when the numbers spit out of the formula, you're going to get basically three different options. You're either going to get a number, the coefficient, that number the formula spits out, PEDC. It's either going to be between 0 and 1 in one case, and in that particular case, you'd have inelastic demand. So the price change is greater than the quantity demanded change. If it's equal to 1, this is something new. It's called unit elastic demand. That just means the price, people's response to the price is exactly in line with the quantities they're buying. And then if the price elasticity of demand coefficient is greater than 1, you have elastic demand, where people's response to the price is much larger than the price change itself. So this is something basically to memorize, whether the coefficient's greater than 1, less than 1, or equal to 1. That will help you understand when the formula spits out a number, what is it telling us? So this is a great way to see if you get it. So go ahead, you look at these three examples. Each one progresses in difficulty, and see if you can come up with the answer. So the correct answers here are going to be unit elastic, elastic, and inelastic. And I've put the coefficients in parentheses for the second two, especially when you had to calculate them. The first one basically is straight off the chart. The second one, we're going to take 50 divided by 10 to get 5. That makes it elastic. And then the last one, you have to do the percent change for the prices, put 1 divided by that, and you should get 0.01. Next up, how about the graph? What does it look, how is the graph of a demand curve impacted by the elasticity? One common mistake students make is they think that elasticity is slope, right? And it's not. This isn't change in quantity divided by change in price. It's percent change. And because it's percent change, the whether or not the demand is elastic depends on where you are on the curve. Higher up the curve is going to be more elastic demand. Down the curve is going to be more inelastic demand. And of course, there's going to be some point in the middle here that's unit elastic demand. So Just something to kind of memorize. I wish there was more to say about this, but that's just how you show in terms of the graph. Now, there are two very special cases with the graph. The first one is this, where you have a horizontal demand curve, and this is called perfectly elastic demand. When you have perfectly elastic demand, what this means is that people will buy any quantity, but only at one specific price. That's what's called perfectly elastic demand. Any quantity, people do not care what the quantity is, but they will only buy it if it's one specific price. The other special case is called perfectly inelastic demand. And in this case, people don't care what the price is at all, the extreme case, but they'll only buy one quantity. So maybe this is like a priceless vase, for example, or vase, depending on how you want to pronounce it. And so there's only one of the vase, right? But it's so valuable, people will pay any price to get it. That would be an example of perfectly inelastic demand. Finally, an application of a price elasticity of demand with total revenue test. So total revenue is basically the price of the product times, that's what that X means, times the quantity sold. In other words, basically how much money is a company making off of a product before factoring in costs. That's total revenue. And what's cool about total revenue and elasticity is you can use it to figure out the elasticity of the demand. So, for example, if the price of a good's increasing and total revenue is increasing, the demand must be inelastic. Why? Because think about this. If the price goes up, people are buying less, right? But they're not buying so much less that that's overriding the price increase that firms like because they can make more money. So it's inelastic demand. People must not care that much about the price if the price is increasing and somehow people are making more money. The amount that people are buying is not changing enough to override the price change. And the opposite's true with elastic demand, where if the price is increasing and total revenue is decreasing, the demand must be elastic, which means people care enough about the price, right? And that's impacting revenues. So you can see how this would be very useful to a firm, right? If the firm knows the elasticity of demand, they can know what a price change will do to their revenues, right? If I have a very inelastic product like insulin, for example, I know that I can raise the price, as immoral as this is, and that would increase my revenues. And this is why companies do this. It's very, very wrong morally, ethically, but that's why companies do it, because they know the demand is inelastic. Whereas, stores like Walmart that sell a lot of elastic goods are trying to keep the price very low, because look at this. If the price decreases, you can actually increase your total revenue if the demand's elastic, because people are going to want to buy a lot more of it if you can bring the price down. So that's all for this video on the price elasticity of demand. Until next time, have a great day.